Hello everyone. Circuit breakers are devices used for isolating the faulty part of the power system from rest of the system. The operating time of circuit breakers depends on the arc extinction time. There are some problems associated with circuit breakers. We know that the power system contains appreciable amount of inductance and some amount of capacitance. When a fault occurs, the energy stored in the system uh, is considerable. The interruption of fault current by the circuit breaker will result in most of the stored energy dissipated within the circuit breaker itself. The stored energy in the inductance and capacitors are mainly dissipated in the circuit breaker, but some remaining amount of energy is dissipated as surges, oscillatory surges in the system. These oscillatory surges are undesirable, and therefore the breaker must be designed to dissipate maximum amount of stored energy as possible. One term associated with it is rate of rise of restriking voltage. It is the rate of increase of restriking voltage and it is abbreviated as RRRV. Usually the voltage in kV and time in seconds. So the unit is kilovolt, time in microseconds. So unit is kilovolt per microseconds. So consider a circuit breaker operation with a circuit with inductance L and capacitance C. Before the current interruption during the time of fault, this capacitance C is short circuited by the fault. So there is no only inductance in the system. So current lags voltage by 90 degree. So short circuit current will lag voltage by 90 degree. But when the contacts are opened or arc is completely extinguished and the contacts are opened, the inductance or capacitance are come in series, and this LC combination forms an oscillatory circuit and produces transient with frequency 1 by 2 pi root LC. If the rate of rise of restriking voltage is the rate of rise of increasing the restriking voltage. It decides whether the arc will restrike or not. If RRRV is greater than the rate of rise of dielectric strength between the contacts, arc will restrike. However, if the arc is failed to, if the RRRV is less than the rate of rise of dielectric strength, then the arc will fail to restrike. So, the RRRV mainly depends on recovery voltage and natural frequency of oscillation due to this LC circuit 1 by 2 pi root LC. We can derive the expression for RRRV. The restricting voltage depends on the factors like inductance and capacitance. The frequency of oscillation is 1 by 2 pi root LC and the voltage V equal to V max 1 minus cos T by root LC. Rate of rise of restriking voltage is dV by dt. While differentiating the equation, dV by dt equal to V max by root LC sin T by root LC. The RRRV will be maximum when sin term is equal to 1. Sin T by root LC equal to 1 or T equal to pi by 2 root LC. Hence, the maximum value of RRRV equal to V max by root LC. And peak restriking voltage occurs when V is maximum. That is dV by dt equal to 0 or sin T by root LC equal to 0 or T equal to pi into root LC. Another problem associated with circuit breaker is current chopping. Current chopping is the phenomenon of current interruption before the natural current zero point. We know that in current zero method of arc interruption, the arc will be interrupted at the natural current 0 point. But in case of circuit breakers like air blast circuit breaker, the extinction power is constant irrespective of the fault current. So there is chance of arc extinction before the natural current 0 point. When breaking low currents, example transformer magnetizing current, etc., the powerful deionizing effect of air blast causes the current to fall to zero before the natural current 0 point. This phenomenon is called current chopping, and this result a high voltage transients across the contacts of the circuit breaker. Here in the figure, I can see that an LC circuit with a circuit breaker. At this point, the current is I, and due to the high pressure of the arc air blast, the arc is extinguished. Then the current reaches to zero value. Then, since due to the capacitance effect, the capacitor voltage increases. When the circuit breaker is interrupted, the capacitance charges to a value up to maximum up to 2 times the rated voltage. So, due to this voltage, the arc will again formed between the circuit breakers, or arc will restrike. So, when the arc is restrike, again there will be large airflow, and again the arc is interrupted and current becomes zero. But again, due to the charging of capacitance, arc restrike, and this process will continue until the current finally suppressed to zero value before the natural current 0 point. This phenomenon is called current chopping, and it causes a large oscillatory voltage in the circuit breaker and the system. Another problem is capacitive current breaking. The cause of capacitive current breaking is like unloaded long transmission line, or in disconnecting a capacitor bank, etc., in the system, causes a large excessive voltage surges. If an unloaded line is there, will not be much current in the system, but there is capacitive current due to the charging effect. So here in the system, inductance is there, capacitance is there, the circuit breaker is connected. When this circuit breaker opens, there is appreciable amount of charge in the capacitor C1. The capacitor is charged to the voltage Vg. So initially the voltage Vg is here, positive voltage Vg is here, the voltage across the circuit breaker is zero. But this generated voltage is it is AC voltage, so it is changing its polarity. So at some point it becomes minus Vg. So the total voltage across the circuit breaker become minus or 2 times Vg. Vg minus 2 Vg is 2 times Vg. That means it may cause restriking of the arc. So again, due to the restriking of the arc, it will form a short circuit path, and the capacitor is again charged to 2 Vg. This process continue until it will multiply as 2 times VGM. And the maximum value limited up to 5 VGM. This process is called capacitive current chopping. In order to avoid capacitive current chopping and also current chopping and capacitive current breaking, the resistance switching is used. In resistance switching, a resistance is connected across the circuit breaker. So, the excessive voltage surges during the circuit interruption can be prevented or limited by using a shunt resistance R connected across the circuit breaker. When a fault occurs, the contacts of the circuit breaker are opened and an arc is struck between the contact. Since the contacts are shunted by resistance R, a part of the current flows through this resistance also. So the current through the arc reduces. When current through the arc reduces, the arc resistance increases and more amount of current flows through the resistance R. Then again the current through the circuit breaker decreases and arc resistance increases and current through the resistance R increases. Similar in such a way, the current through the circuit breaker decreases up to zero value or where the arc is extinguished. The shunt resistor also helps in limiting the oscillatory growth of restriking voltage. And while using a resistance switching or shunt resistant, the natural frequency of oscillation of the circuit is given by 1 by 2 pi root 1 by LC minus 1 by 4 R square C square. So main problems associated with circuit breaker are current chopping and capacitive current breaking. Current chopping is mainly associated with air blast circuit breakers whose extinguishing power does not depend on the fault current. And in order to protect the circuit breaker from current chopping and capacitive current breaking, resistance switching is used. Thank you.